Good day, students. So, for this semester, I will be teaching digital IC application laboratory. And the main course outcome of this laboratory is to develop a digital circuitries by means of behavioral, data flow and structural model. So, when it goes to Bloom's taxonomy in level, we will be applying the concepts of STLD to write a VHDL programming. And the second outcome that we will be achieving after going through the course is we can simulate the VHDL models using CAD tool. Presently what we are using the tool is xilinx 14.2 version we are using. And the outcome 3 is we will be able to synthesize sequential and combinational logic circuits. So these three outcomes will be achieved after completing the lab course. So our main objective is the students are required to design and draw the internal logic circuits of the following digital integrated circuits. And to develop VHDL Verilog HDL source code, we will be only developing VHDL source code. Perform simulation using relevant simulator, analyze and obtain the simulation results using necessary synthesizer. We will be using xilinx ISC software latest version. And we will be also synthesizing these circuitries in FPGA xilinx board. So these are the experiments that we are going through in this semester, out of which we will be doing two experiments. First one is realization of logic gates. Second one is a design of full adder using three modeling systems. Third one is 3-to-8 decoder with IC 74138. So we will be designing we will be writing a VHDL code for 74138, and also we will be going with 8-to-4 decoder, which is opposite to the 3-to-8 decoder, and we will be going with 8x1 multiplexer and 2x4 demultiplexer, 4-bit comparator, D flip-flop, decade counter, shift register, 8-bit serial and parallel serial out registers, fast in fast out, multiplier and accumulator LU design. These are the experiments that we will be going to design in our VHDL laboratory. So the first program is realization of logic gates. So we will be going with the realization of logic gates. See, here the truth table itself states that if both inputs are 1, output is 1. Otherwise it is 0. So AND gate IC number is 7408. AND gate IC number is 7408. We can say AND gate is used for logic multiplication. We simply say AND gate is used for logic multiplication. We can define AND gate in any one of the logic. Either we can say both inputs are 1, output is 1, we can say. Otherwise, we can say any one of the input is 0, the output is 0. So, in both ways, we can design the circuitry. Likewise, if we go with the another gate, if we go with the VHDL code, see, first of all, we have to write the programming in such a way that we have to initialize the libraries. First, library IEEE semicolon, which will be ending the semicolon used to end the statement. So, library IEEE followed by use IEEE.std underscore logic 1164. 1164 is a package. It is a package. So we will be using in the library IEEE, we will be using 1164, where we will be having basic gates and all these things. So then we have to create the entity AND2 is, we will be porting the entity with AB as inputs, STD as standard logic, Y as output. Then we will be ending the entity. If you take the data flow programming, so data flow programming, how it will be? Data flow program will be direct statement. Y is assigned with A and B. Y implies A and B. So AND gate is already in the 1164 package. The AND gate is the primitive gate. It is already in the package. So Y implies A and B, which is called as a signal assignment statement. It is a signal assignment statement we have already provided. and behavioral. This is the, and we will be ending the architecture. If at all, if we want to write that in behavioral, we can go with like this. Architecture, behavior of the AND gate is, we begin in the behavioral, we will use the statement called process statement. In this, in braces, we will be having sensitivity list. This sensitivity list represents that any change in these two variables, any change in two, the output will change. That's what means sensitivity list. So obviously, inputs will be in the sensitivity list. A and B are in the sensitivity list. So as a statement previously, according to the truth table, what we have defined? If both inputs are 1, then output, if both inputs are 1, then what will be the case? Okay, let me change the coding. So if both inputs are 1, y output is y. So a little bit change. Y will be assigned with 1 and y is assigned with 1, else y is assigned with 0. So that is the case. This is the behavioral program. Now we will be going with how to execute this program in xilinx software. The process one by one step we will be going with. Now if you take the thing here, now file, you go with new project. In this, logic gates is the first program that we are going. Logic gates. Next, you will be assigning family to Spartan 3. We have having the basic kit of Spartan 3. Device XC3S250, the device with 250 we are having. Up to a package we are taking up to 256 and speed we are providing. And the synthesis tool we are taking XST, simulator, iSimulator we are taking. And we can go with VHDL or Verilog, but we will be going with VHDL. The library what will be preferring is VHDL 93. We can go with VHDL 2000X. So now I'll be finishing. Now we have to add the new source. In this VHDL module is there. There I'll be writing and to programming which we are writing and to. Here I can directly port it. A, B and Y. We are given. Output is Y. The next finishing. So here and 2 is already there. So I'll be giving and 1. And 2 is already there. So I'll be giving and 1. So here we can directly signal assign y implies A and B. Y implies A and B. So here once it done, you go with syntax checking. Run. We go with syntax checking. So here semicolon should be there. That is why there is error. That is the advantage of this simulator. It can easily identify where we are having the error. Now it is completed. Now if you go with the simulation, now we will be getting the simulated waveforms. Now what we will be doing is we will be force constant 0, apply force constant 0, then run it. 0 0 will be getting. Now B, make it force constant 0, sorry 1, run. Even 0 1 also 1. So force constant, this one will making 0 and 1 0. Next one is again will be running 1 0 also 0. Now last one is force constant 1 1. 1 1 is 1. If you see the waveform, see first one is 0 0, then 0 1 also 0, 1 0 also 0, 1 1 is also 1 1 is 1. So with this you can write in data flow programming. Now it was replaced with, if at all you want to replace with behavioral programming, simply I'll be copying it. Code and I'll be pasting it. So now I'll be executing it. Now I'll be going with the So previously I have given force constant. Now I will be giving force clock. We can also give force clock. Leading edge 0, trailing edge 1. We will be giving, let us say we can give 1000 as a force constant. Force clock we have to give. Force clock 0, 1, and it will be given as 500 up. Then we execute it. Now if you see the starting, here we are having 0 0, we have after 0 0, then 0 1, then 1 0, then 1 1. The same. Either way you can give force constant and force clock. Likewise, if you go with the OR gate expression is, if both inputs are 0, output is 0. Rest of the case output is 1. So you can write the programming, if both inputs are 0, output is 0, else 1. You can write it. So it is a logic addition, and the same the programming. Previously we have placed A and B. It can be replaced by A or B. And when it comes to behavioral programming, if both inputs are 0, then output is 0, else it is 1. Then NAND gate, which is a universal gate, it is the opposite of the inversion of the AND gate. If both inputs are 1, then only output is 0. In rest of the case, it is 1. So the code, if it is a data flow, and this A NAND B, directly it will be calling the primitive gate from the library package 1164. Whereas if you take the code, if A is equal to 1, B is equal to 1, Y implies Y signal assignment is 0, else 1. So likewise we have given for the NOR gate and also exclusive OR gate. Exclusive OR gate is both inputs are directly, you can call the primitive gate, Otherwise, you can say if A is not equal to B, then Y is equal to 1, else Y is equal to 0. So in this way, you have to write the code for the logic gates. This is the first experiment. I hope you understand it. I'll be sharing this PPT. So please work it on it and execute for all 6 gates. Those are AND gate, OR gate, NAND gate, NOR gate, exclusive OR and also exclusive OR gate. Exclusion OR, exclusive OR and exclusive NOR gate. Exclusive NOR gate is opposite to exclusive OR. So these are the things. So for today's session, I am ending the lab demo. Hope you understand it and practice it by yourself. Thank you.